Assalamu alaikum. Our today's session is specifically related to the quantum algorithms. And we have two different terms here. One is the quantum computing, and the other one is quantum algorithms. So the quantum algorithms are actually which are made to run on the supercomputers, the quantum computers. So we have the classical computers which are which we are using in the day-by-day tasks, and then we have the supercomputers. Like from our early days, we have been reading about and listening about the supercomputers, and we also call them the most powerful computers as well. So in the supercomputers, like there are superpowers. We would like to call them the sometimes the servers as well, or we would call them like the best computers over there. But from the 2019, Google has introduced the quantum computing. So what actually happens is in the computing, so we all know that computers only understands the bits, which is 0 and 1. So for the 0 and 1, we have different combinations, like we have 0 1, 1 0, 0 0, and 1 1. So we have these four combinations. All of our data is computed into these values, and that is stored in the memory of our systems. So whatever we see here, let's say we are seeing the slides here, or if we have some audio or video, then behind the scene, everything is encoded into these binary numbers, which is 0 and 1. And for the for the simple classical computers, it just helps them run one at a time. So what are actually one and zeros? These are the switches, which is 0 and 1. So at a time there will be one is off on and other one will be off. So it is 1 and 0. And our classical computers just process them in the shape, like in the parallel, not in the parallel, they process them in sequence. Then the supercomputers came, then they helped this to run in the parallel, and finally the quantum computers came that helps them run in all the direction. So let's say we have different combinations over there, and for the 0 and 1 we have the four combinations. So what the simple computer will do, they will process 1 2 3 and 4. And what quantum computing does, they just put in everything, like it's a capture over there. They captures the whole scenario and shows the output. So there are different algorithms which helps in like during the quantum system. So actually quantum computers have different shapes, like the normal computers. It's like a chandelier over there, different shapes and everything. So we can continue with this session. There is much more information. Actually, we will there is just an overview. So actually, we will be going through all of the details regarding these algorithms, which we can implement and then can produce the outputs. Okay, here we have the introduction for the quantum ready algorithms, and then future landscape of innovation, key advantages. Definitely, there are advantages. So, for the quantum computing, for bit, we have already like got the introduction, and then we will go through all of these steps one by one. And we have better strategies for adopting, how the organizations can adopt these systems, and how this can be used. And then we have the industry impact and use cases, and then we will have conclusion. Listen to this session carefully, because I will have some questions from you as well. Okay. I have already explained regarding the quantum ready algorithms. So we have large number of maybe the data sets or there are things which need to be processed, then we use the quantum computing. So let's say there are the combinations. I was listening to a podcast, and we have 10 to power 90, which is 90. So let's say we have one, and then we have 90 zeros next to it. And if we gave this to the classical computer, which is our computers, and it will take like years and years, like million years, like infinity years to make the possible combinations. So what this actually does is they're used to create and produce the possible combinations against these numbers. So what quantum computing can do, they can just flash on it, and within a few hours or few days, this can produce the results. So this is like it is pushing the infinity. So something like if there is a there is some object which we can throw in the space, and then we create an algorithm to find that object. And if we assign that to the simple computers or the classical computers, they will find it step by step, like where from we can find where this could be, like in the whole universe. Then we have the quantum system that has like its own algorithms. It just spreads away, and that can find it like really quickly. And we have the hybrid execution earlier, but like we have the supercomputers, then we have the classical. So that was a bit better from there. And then we have the road to scale quantum hardware. And like this is all like summarized in my like earlier what I was talking about. So it just talks about that what are the capabilities, how this can handle the large data set and so on. And what is the importance? So there are different algorithms which are in the quantum system, and everyone has their own benefits, and it is being used in our in their own like domains. Let's say for the ML, we have for the AI, for the healthcare departments, and for the data processing and security. So we have different algorithms that are applied in different ways. So what are the advantages? Exponential speedups with Shor's algorithm. So we have a Shor's algorithm. Actually, I do not have something like practically to show over there, but it is something like if there is a function, let's say this is a function, and then we pass the value, and then it outputs it. So if we pass some, we have a data set, and against certain values, it outputs the if this is a true or false, let's say. So we pass, let's say we have 1 to 100 numbers, and we pass to this function, and it outputs if there is a special number in between, let's say 70 over there, which is true, and all the rest of them are false. So for the simple systems, it would take like from 0 to 100, and then it will process one by one. So and for the Shor's algorithm, it provides the system in which like we pass the whole data set, and it outputs the values what that function actually does is. So we have quadratic improvements via Grover's algorithm. I have not studied this Grover's algorithm actually. I am only known with the Shor's algorithm. Hope you can get an idea from here, and then you can have a go through and read this one. And computational complexity. So definitely there are many things which need to be computed for the maybe for the organizations, for the different companies, if they have their financial data, or they have to take some decisions based on the company's data, then they can like get benefit of these algorithms and compute the outputs, and also can help them in solving different kind of problems as well. So we have the quantum approximate optimization algorithm, leverages quantum superposition to efficiently solve combination optimization problems. So here we have a term which is superposition. Actually, the superposition is uh, when there is an object which can be either true or false. Let's say we have a coin to flip, so we can only determine its value when we have, like, it's on the ground or we catch it, so if it is heads or tails. And what this quantum system does is, when it is like, if we flip the coin and if it is in the air, then normally we cannot determine what would be the output. So until we see the output. So this system does is, in the air, it processes it and this can determine, okay, this will be the output. Although this system is not 100% correct, and everyone agrees this with as well. So because uh, when it comes to the probability, so for the probability system, uh, the quantum computers do much mistakes than the normal systems, like the classical systems. So but it, what it does, it at least it can do a much faster things, better things. And like the speed is the important thing, like in every aspect whatever we see there. Then we have variational quantum, and it leverages the hybrid models to efficiently solve optimization problems, enabling faster coverage and improved accuracy, and molecular simulations and complex system analysis. So if when it comes to the physics and chemistry, and there are uh, different actions and reactions going on, then uh, like what it does, it helps in making the combinations and then breaking down them in the outputs. So when there is an option which can have multiple combinations, this system can help in there what would be the probability. Then it comes the superposition as well in there involved, like what will be the actual position of the output. Then we have applications in logistics and finance. And as we are in the tech system, and there are companies which are like doing the logistics, and mm, through the AI development, through the AI implementation, along with the quantum systems, they can help them compute the data. And they also suggest the, along with the help of AI, it provides the uh, techniques for them to like improve the business. And simulating complex quantum systems, and accurate simulation of nature's phenomena enable precise modeling of it's like I already shared, there are many things in which, like we do compromise on like, let's say, on the outputs or what actually is there, and sometimes we don't. So if we see, if it is going to take the pictures of a galaxy, uh, then we do compromise on some results, but actually we do want to see that as well. So if there are some accuracy issues, that's fine for us to see, at least it is processing something that can be um, accessible, or we can get the information. And accelerating drug discovery processes. So uh, as there are actions and reactions going on in the against like in the chemistry, so it is helps them trigger the information and then get out the results as fast as possible. And innovation in material science and chemistry, so this is the similar, and it helps in precise simulation of molecular reactions. And as we have the powerful thing here, which is the quantum system, If we align it with the right thing, let's say the machine learning and AI, we have to process the data, and then we have to take the outputs. This is the system that can like do the magical things. So let's say we have a large data set, let's say of uh, last 100 or 200 years. Then we come to compute that data and produce some results. This is the system that can help to do it like so much quickly. And potential to reshape AI capabilities, definitely it is the system that helps in recognizing the patterns. And for the normal systems, it takes years for them to process, as in the fast growing technologies and in this era. So it is most important to follow these steps. And with the help of quantum and AI, it helps to produce the better results and the faster results. Hybrid ML models combining quantum and classical. So it works with the both. Uh, like for as I said earlier, we have the classical systems, and I think we should add the super computers there as well. So they work together and produce the results for all the in the problem solving. And it is not like in that in simple way to process the data in one dimension or two dimension. It is I said it's like something magical over there. Whenever we have to process the data, so it does not take it like in the sequence and one by one. It processes everything in the parallel. It is next something next to the parallel that helps in making the output. And we have the industry impact and use cases, and molecular structure identification. Then we have speeding up clinical trials and R&Ds, personalized medical opportunities. So if it applies to the drug discovery system, this is the system that can help in like normally detecting all uh, the things which are in the so whatever we see is like if there is some reaction, and we have to calculate what how this happened and why this happened, then this is the system that helps in there for the R&Ds. And we have the one option here, which is the innovations in financial modeling. As we discussed earlier, it just takes the data and then processes the data, and then it suggests based on that data what actions should be taken, what could be the risks there, and how can we like avoid the mistakes which were made in the previously. So it is just like kind of that helping in the financial modeling. And then we have the real-time market simulations. So as we see the cryptocurrency there, so there are the real times prices changes, and there is a lot more going on in the exchange system. And when it is there to compute the total values, so are the complex variables, then this is the system that helps in doing that efficiently. And advancing artificial intelligence. So we have all the data, we have the data sets of the years, but if you don't, if you can't process that and then can get some results of that, or if we get some results like by putting years of computation on that, then that time has passed and something new comes. Let's say we discover discover a disease, and for its cure, we have to wait like 2, 3 years. We can't wait, definitely. Then this system helps in finding the right solution against the provided data. Like it is above and beyond the thinking. And cybersecurity challenges and solutions, definitely. As I was talking about the cryptography, so it comes in with the cybersecurity. And mm, uh, uh, like if we see, there are regular computers, which are the classical systems, and then we suddenly come with the supercomputers, and then it comes to the quantum system, and that is the thing that helps in processing all the systems, and helping in the cryptography as well. And future landscape, and then we have the emerging trends in ready development. So it is not like these systems are only available with the big companies, as the Google launched their first system, quantum system, in 2019. And it is also, now we have the cloud-based access that is that can be found there, and grow industry collaborations and consortiums accelerate quantum ready algorithm development, fostering shared resources, standardization, and cross sector innovation to overcome technical challenges and drive scalable quantum solutions. So, these are overall the concepts that I have shared earlier. And if someone want to like get the deployments and want to learn these quantum systems and integrations, then we have some way here, which is the hybrid quantum classical systems deployment. And then we have scalable quantum hardware trajectories and timeline for in the quantum adoption, projected to accelerate over the next decade with early integration by 2028. And widespread use the critical industries by 2035. So as we see, like there are long targets for these systems to actually get in the race. And we have the practical strategies. um, how can we implement this within the organization? So as I have added some points here, so I will ask this question to, as we have this on the view as well. Is there anyone of you who would like to answer this? How can we aware the organizations regarding the quantum?
We can start trying the algorithms just like you told us Shore's algorithm and Grover's algorithm. We can make a demo of them and share that with the organization within our organization.
Can you come again?
Basically, you want to build a quantum awareness within your organization, right?
Yes.
Okay, so what we can do is we can have a practical demo for particular algorithms, just like you shared Shores and Grovers, that can help them in understanding those algorithms. Okay, once we have made something practical, then obviously it will automatically increase the awareness of employees and their interest as well.
Mhm. Okay. Okay, good. Yes, the first thing is, if we know something, then we can implement. So if the organizations are not aware of these systems, how they work, where they to get implemented, and how we can get uh, uh, used to it, or we can get benefit of it, then definitely we can aware the organizations, and then they can implement. And definitely the Glowingsoft will work on this, and we will this is the normal thing. Like if we think, if it is only the quantum computers, if we do not have, we can't implement that. But actually it is more related to the quantum algorithms, which can be implemented and then can be computed to help in like different ways. And we have some experimental projects here, and there are many things in this universe which are already proven. So what we do is, if we have to, let's say, if we have a complete lab in which we have uh, all the things available, and if there is a disease, and we have to make its cure, like we have to make its medicine, then what we do is we want something which is uh, like we define some formula that could come up with the combinations of all these medicines or some of these right medicines which can compute to that output. So instead of what normally we do is there is especially a term I forgot that one, like for making the medicines, what the scientists do is they do the experiments one by one which each of the medicine, and then they take the outputs. So what we can do with this system is we just provide them the details and they compute everything, like all the possible combinations they just make, and then based on the data they can suggest, okay, you can use these medicines to make the medicine of this disease or something. So like instead of wasting resources, time and everything, this system can help in uh, getting the right output quickly. And definitely this is for the scaling for any IT company or the workforce, it needs to be added some long-term investments, as the outputs are uh, not that much faster or maybe not that much accurate, but this helps in getting something like with the big systems. So when we apply it, the outputs will be definitely surprising. And we have this all, and here's a recap. The most important thing that is related to this is only the speed and optimization. So everyone says that if there is a speed and accuracy, that is the best system. And what today's system are trying to achieve is the quality and speed. So if we see the mobile technology, they focuses on the better camera, the better resolution, the better battery, and then the speed as well. So all the systems which try to get the better speed, uh, then we can have, like if we have some systems, then definitely we should move to that one. Let's say if as we are using the AI, and along with the development with the engineers, if we can implement the AI and then can output the uh, code or app, whatever we are doing, then this can result in like significant improvements. And that was regarding the organization, which Omar has already answered the question. So I have one thing more to share with you. Just a minute. So here is the Shor's algorithm, which we discussed earlier, and factoring large integers efficiently. That I told you that we have some function over there in which we have to process some values, and it determines the output. Then we have the Grover's algorithm, unstructured search, searching a database with quadratic speedups. And then we have quantum approximate optimization algorithm, QAOA, which is solving combinational optimization problems. And then we have the variational quantum eigensolver, and finding the ground state energy of molecules and complex systems. Then we have the quantum machine learning algorithms, QML, and quantum phase estimation, estimate eigenvalues and quantum systems, and HHL algorithm, Harrow-Hedison, and solving linear systems of equations. So if we go through all of them, so and try to implement in our system, especially for the developers, and they can find some more meaningful information from them to get in work with their system. Let's say if you get some technique here for the Grover's algorithm, and how this system works is, then if we can implement this algorithm in our like MongoDB or search APIs, then if we know some information regarding that, how these things are, definitely that can be helpful and can produce good results. So this is all from today's session. Hope you enjoy it. And if you have any questions, please, you can post here.
Okay, sir. My question is this: that how we can use the quantum to enhance our productivity, or for example, to enhance these all issues that we face when our app is in production or we are moving towards the production.
Okay. So as we discussed that we are not directly implementing the quantum computers in our systems, but we are implementing the algorithms. That was the last thing we discussed, and I showed some of the algorithms. So if we have to prepare some scenarios, and let's say we prepare some data and train our systems, then we can have the possible outputs. So what these systems does is they just make the predictions based on the previous data, and how efficiently and how accurately these systems make the outputs, uh, that is important first. So if we train them, we provide some data and get the outputs based on our uh, applications data, then that definitely we can use in that way in our production apps to get the outputs.